Let's talk about transformations of the quadratic functions, and in particular we'll start with the parent function and we'll transform it in order to get the graph of those functions that represents the most usual cases of single transformations. Okay, the parent function is y equals x squared. Let's graph it. We need the chart for this one, and that's the only function that I really need the chart of. So start with x, the chart, y equals x squared. I'm gonna put the usual 5 points: 0, 1, -1, 2, -2. I remember from when I derived the parent function that 0 goes to 0, 1 and -1 go to 1, and 2 and -2 go to 4. Then that gives me the following points. That's the 0, 0. Then we have 1 goes to 1 and -1 to 1. 2 goes to 4, which is over here, and -2 goes to -2 goes to 4 also. And these are the points. Now if I graph that, I'm gonna get the U-shaped curve, or my parabola, which is symmetric about the y-axis and has a vertex at the origin. Okay, now let's write next to it what we have done. This is the parent function. Now how do I get the graph of y equals -x squared from the parent function? I see here that there is a negative and it's in front of x squared. First, that means it's not, the negative is not associated directly to x. If it was associated, there would be a parenthesis. That means it's not an x transformation. It's not a horizontal transformation. What it is it takes the parent function and it flips it, and that gives you a new height, meaning it's a y transformation. It's going to do a vertical flip. It's not going to be a horizontal, it's going to be a vertical flip. Now how do we do a vertical flip? Every point that's above the ground goes below the ground, and vice versa. But here I only have above the ground or on the ground. Let's start with this point. It's 1, 2 above the ground is going to go 1, 2 below the ground, and I need to go in a vertical line. And let's say this point is basically 1, 2, 3, 4, 5, 6, 7, 8 divisions, 8 boxes, but it's essentially 1, 2, 3, 4 units. Let's just use units on this one. It's gonna go 4 units below the ground on the same line, so it's gonna go right there. That point also is gonna go below the ground, and you see those two are also in symmetric positions, and that point is gonna go here. Now what happens to the vertex? The vertex is on the ground, so it's not going to be affected by a flip. It stays on the ground. What happens to the axis of symmetry? Well, it's gonna remain the same axis of symmetry, because you flip a vertical line vertically, you're still gonna have the same line. Also, since the vertex remain unaffected, and we know that the axis of symmetry goes through the vertex, that's gonna be the axis of symmetry, meaning make sure that whatever we're gonna draw, left and right, is going to be symmetric about the vertical axis. Alright, and that is what we are getting. Okay, this is the graph of y equals negative x squared. Let's go to the next one. Y equals x squared plus 4. Now, is this an x or y transformation, horizontal or vertical? Well, the plus 4 is not directly associated to x, so it's not horizontal. You take what you got and you go 4 steps up. Let's do that. So it's a vertical. Plus 4 means go up. Let's start with the vertex. It's gonna go 4 steps, 1, 2, 3, 4, and the vertex is gonna get over here. What about this point? It's also gonna go 4 steps. Each step is 2 divisions, 1, 2, 3, 4. So it's gonna go right here. I know that the other point is gonna be in a symmetrical position, so that point goes here. And then let's move that point. Is also gonna go 4 steps. Basically I'm doing a shift, and it's gonna get right there, and in a symmetrical position that point is gonna go there. Okay, the same axis of symmetry, because just by moving it's not gonna change. Also, since we have the vertex, we know that the new axis of symmetry is gonna go through the vertex. Make sure everything is symmetric, and this is the blue curve, which has equation y equals x squared plus 4. I'm gonna leave the y equals x squared minus 5 to you, and obviously you're gonna have to start with the red line and go down 5 steps. Now let's do this one. Y equals 2x squared. First of all, is it an x transformation or is it a y transformation? Horizontal or vertical? It's not horizontal. It would be horizontal. It would be horizontal if there was a parenthesis here. That means the 2 was associated directly to x. That would mean modify things left, right. Because it's not associated directly to x, that means it's a vertical transformation. So take the x squared that you used to have, make it double, and that's going to give you the new height. So make all the doubles of the original, of the parent function, double. And that's going to be the I guess the orange or yellow. Alright, let's start with the vertex. Now if you make it double, it's already at 0. It's not gonna change, still gonna remain at 0 height. But if you take this point and you double its height, it has height 1, double it, it's gonna go over here. Same thing is gonna happen to that point. Needs to be symmetric anyway. What about this point now? This point has height 4, so when you double it, it's gonna go to height 8. Where is 8 now? It's 5, 6, 7, 8. It's gonna be right there. Okay, so that's 4, that's 8, and it's double. Of course, that point is gonna go right there in a symmetric position. And there's gonna be an axis of symmetry for this line going through that vertex, and when I draw it, I'm gonna draw it symmetric, so it's gonna go something like that. Oh, let's try again. Okay, and this one now. Alright, that is the graph of y equals 2x squared, which is twice as tall. Y equals 2x squared. Now this could be interesting here. Before I get that, I want to emphasize that when I made the points taller, I went straight up. I didn't go at all left and right. Okay, straight up. Okay, now let's go to this one. That's 1/2 x squared. Using the same logic, I see that it's not an x transformation. It would be if it had a parenthesis like that. Because it doesn't have a parenthesis, a vertical transformation, it tells me whatever you had, make it half, and that's going to be your new height. Okay, whatever I had is the parent function, the red one. Let's make it half. So all the points are going to go straight down. Let's start with this one. It's 2 divisions, or 1 unit is going to go to half unit, which is 1 division. So it's going to go here. You see, it's going to go straight down. Now what about this one? That's at 4. Half of it is 2. So it goes at 4, became half. And that point is also going to go down in a symmetric position, which is from 4 units to 2 units. And I forgot this one. It's at 1 unit, goes to half unit, which is 1 division. And then I have the vertex. The red vertex is at 0 height. It's gonna go half of 0, which is still 0. And if I the same axis of symmetry, it doesn't change, needs to go through the vertex anyway. So if I didn't know if it changes or not based on the transformation, once I have the vertex, I know that this is the axis of symmetry. Everything's symmetric around about that axis, and this is the transform function that has equation y equals 1/2 x squared. You see, it's shorter than the red. It's not wider, it's just shorter. If you check the width, they both have the same width, but it's just shorter. And let me fix something real quick, that I need to extend it the same amount so it doesn't give the impression that it's wider. Okay, well, that's how we do vertical transformations, single vertical transformations starting from the parent function. I left this one for you. So let's move to the next one and see how we do horizontal transformations. Okay, horizontal transformations. We're still going to start with the parent function. How do we start? We do the parent chart. And what is the parent chart? Is 0, 1, -1, 2, -2 for the inputs, 0, 1, 1, 4, 4 for the output. That's going to give me the usual point, which is 0, 0. Maybe I should mark this also to have units every 2 divisions, so I can, if I have to cut it in half, I'll do it a little easier. Okay, almost done with this. And I'm gonna start plotting those points. The first point is 0, 0. That's gonna be my vertex, which is right at the origin. 1, 1 and -1, 1. 2, 4 and -2, 4. And now if I connect those, make sure you do it kind of round it at the vertex, it's not pointy. This is my parent function y equals x squared. Okay, knowing this, I will be able to graph that function that's negative x in a parenthesis squared. Now notice something, the negative is the only difference, and that negative is associated to x. That's a horizontal transformation. It tells me that I need to flip horizontally the parent function. Now if I flip the parent function horizontally, let's see what happens to that point. Is 2 positions to the right, it's gonna go 2 positions to the left, so it's gonna get here. What about this point? It's 2 positions to the left, or 2 divisions to the left, it's gonna go 2 divisions to the right, so it's gonna get there. What about this point? It's 4 divisions or 2 units to the right, and it's gonna go 2 divisions, 2 units or 4 divisions to the left, and whatever used to be on the left is gonna get to the right. What about the vertex? Well, the vertex is at 0, so it's not gonna go anywhere. It's already 0. Negative of 0 is 0. It's not gonna move. So I see that if I draw the graph, what I got is the same as the parent function. That's because the parent function has a symmetry about the y-axis. So if you flip it about the y-axis, one branch is gonna fall on top of the other, or if you reflect it, you put a mirror here and you reflect it, the one branch is gonna have as image the other branch, so nothing changes, meaning the same exact curve is the graph of y equals x squared and of y equals negative x in a parenthesis squared. Let's do the blue one now. The blue one is also an x transformation. The x and the 4 are associated, they're attached, you can't separate them, so that's a horizontal transformation. Common sense is telling me if you add 4, move to the right, but because the horizontal transformations are particular, I'm going to go to the left. So all the points are going to make 4 steps to the left. Sorry. For this one, I'm going to start with again with the red parent function. Let's start with the vertex. 4 steps to the left is 1, 2, 3, 4. That's 4 units or 8 divisions. So that's going to be my new vertex. What about this point now? It's going to make 4 steps. 1, 2, 3, 4. And it will get here. Now by symmetry I can already tell that this point is going to go over here. But let's count it. 1, 2, 3, 4, and it will get here. And let's take that point. It's going to be 1, 2, 3, 4. That point is going to get there. And what about this point? That red point is going to go to 1, 2, 3, 4. It's going to go right there. Okay, now remember something. There is an axis of symmetry going through the vertex. Now the axis of symmetry shifted to the left. We know that it should go through the vertex, and also we know that if I shift this axis 4 steps, where will it go? 1, 2, 3, 4. So it's going to be right there going through the vertex. So when I draw it, make sure it's symmetric about that axis. So it's like, that's one branch, that's the other branch, and that would be the graph of y equals x plus 4 squared. Let's move it a little. Okay. Well, what about the x minus 5? It's the same deal. It's an x transformation. I'm gonna it's gonna happen horizontally. It's x minus 5. Common sense is telling me move to the left, but I'm gonna go against common sense because that's how horizontal transformations work. So I'm gonna shift it to the right, starting with the red graph, and I'm gonna leave this up to you as an exercise. So I'm gonna leave it to your exercise. Okay, now what about this one? 2x and all of its square. Again, it's an x transformation. It's a horizontal transformation. That's because 2 is attached to the x inside the parenthesis, so things happen left, right. Common sense is telling me 2 times x is gonna be wider. Because it's horizontal and it doesn't follow common sense, it goes against common sense. I'm gonna make it half. So let's see what happens to that point. It's gonna become half as wide. Okay, I go horizontally. Let's start with this point. This is at unit 1. It's gonna go to so that's the distance of it from the wall, the horizontal distance. I'm gonna make it half from the wall, so that's gonna go here. It was that big, now it's half, so it's one division, and that point goes here. In other words, it moves horizontally. Of course, the same thing will happen to that point. It's gonna move horizontally, gonna go half the distance that it used to have. It's gonna be somewhere here. Now what about this point? Same deal. It was 2 units. It's gonna go at 1 unit from the wall. It's gonna go here. Of course, this point is gonna go here. You can utilize symmetry. To find symmetry, we have to also find the vertex. Well, what will happen to the vertex? The vertex was here. I always start with the red function, and it's right on the wall. When I make it half as wide and it's exactly at 0, half of 0 is 0, so it's gonna stay here. And let's see what happens now if I connect. It's going to be a more narrow parabola. Okay, you see it's not taller, it's narrower, and this is the y equals 2 to the x squared. Lastly, let's do this one. It's 1/3 x, all in a parenthesis, squared. It's not a vertical transformation, it's an x transformation because the 1/3 x is attached to the x. Common sense is telling me that's going to be narrower. It's going to be 1/3 of it, but because horizontal transformations don't follow common sense, I'm going to make it triple as wide. It's going to be wider. It's going to be triple. Let's start with the red graph. Let's start with this point here. Its distance from the wall was 1. Now I'm going to make it triple, so it's gonna be 1, 2, 3. It's gonna go over here 3 times. What about that point now? Well, its distance from the wall is 1. It's gonna become triple, and it's gonna get right there. Okay. What about the vertex? Well, we're stretching. It's on the wall. Nothing's gonna happen. Another way to see it is if you stretch symmetrically to the right and to the left, what's in the middle is gonna stay in the middle, and the vertex is right in the middle, so it's going to stay. I'm gonna try to put it somewhere that doesn't hide all the other points. And we have two more points, two more red points, this one and this one. I may have to move some of them, or if I can fit it. So it's 3 times. Let's move this. And I'm gonna move that too. Okay, so let's go back. We're at this point and we're gonna make it 3 times wider. Now this is at 2 and it's gonna go 3 times 2, 6. Let's see if we have 6. 1, 2, 3, 4, 5, 6. Okay, we do have a 6, and it's going to be right there. It's gonna move horizontally. Okay, this is a horizontal stretch, and then we have this point is also 2 away from the wall, is gonna go to 6 away from the wall. Let's see where 6 is. 1, 2, 3, 4, 5, 6. So it's gonna move this direction until it gets at triple distance, which is over here. Alright, so I have this point, that point, that point, that point, and that point. Let's connect them. That doesn't look very good. I'll try one last time and then take whatever I get. And then the last point, the other branch. Okay, and this is the graph of y equals 1/3 x and all of it squared. Okay, that is it.